Hello, citizens. I'm going to talk to you today about titanium dioxide nanoparticles, which are often found in our food and in other everyday items or things that we consume, okay? And we need to be aware of what they are and why are they in our foods. Now, the title of this presentation is called Titanium Dioxide Nanoparticles in Food and Personal Care Products. What do we know about their safety? If you want to read more about this, here's the link. Go and read more. But I'm giving you a small summary of what the scientists already said about these nanoparticles, okay? So first, what are nanoparticles? They're just small chemicals, very small chemicals, very tiny, and that's what they're called nanoparticles because they're small particles. And now they're used as pigments due to the brightness and opacifying properties. What this means is that the industries, they like to use these nanoparticles because it makes the products less transparent. Let's say if I have a glass, let's just pretend that I put nanoparticles in glass. Rather than make it more visible to the other side, is going to be less transparent. And that's why sometimes the industries, they put this in candy, because when they're mixing all the sugar and all the dyes and everything, the candy might look very transparent. So what they do is they just add more of these particles to make it less transparent. They also use this in gum. Sometimes they add this on gum to also make it look less transparent, more opaque. And these particles absorb and scatter UV light, something that is useful, and you will see why. Now let's look over here, okay? So applications of titanium dioxide nanoparticles, they're used in cosmetics, hygienic products such as sunscreens, toothpaste. We talked already about that they scatter UV light or they absorb UV light, so that's why industries use it. Some industries, they use it in their products and sunscreens. They're also using in foods as food additive E171. So if you see something that contains E171, you should immediately know that it contains titanium dioxide nanoparticles. Now, all of this right here, we don't really care that much because we're not going to talk about, we're just mainly, our main focus is this today. So let's keep going. Now, let's talk about the effect on titanium dioxide nanoparticles shape on their toxicity. What this means is that the the amount of toxicity in the cells, either the rat cells or the human cells, is going to depend on the shape of these nanoparticles, okay? For example, this scientist and his colleagues, Allegri et al., showed that nanofibers had higher toxicity than nanoparticles in alveolar carcinoma epithelial cells. What this means is that these nanofibers were more toxic than these nanoparticles, which were round in shape, okay, in this type of cells. Now, another scientist, Porter et al., showed that mice exposed to inhaled nanobelt-shaped nanoparticles had more lung damage and inflammation versus nanoparticles. So belts are also look kind of like this. The scientists, they show that mice that inhaled these nanoparticles, um, the nanobelts were more toxic as opposed to the nanoparticles. And the industries, they choose how they want to make it, the shape, because different shapes are going to have different properties. Now, let's talk about oxidative stress and the toxicity of nanoparticles. Don't be scared. I'm going to explain you right now everything. This is just an image showing you that. Remember that we said that nanoparticles absorb light. Well, this is how they do it. This is complex, but all we care is about this part right here: oxygen and water. Okay, so when these nanoparticles are inside our body, they're surrounded by oxygen. Now, when some light, let's say UV light, comes inside and hits this nanoparticle, this oxygen that was around here, the nanoparticle, the titanium dioxide, is going to turn this oxygen into an oxygen that has more energy in the form of O2 minus, okay? And now this has more energy. They also are going to turn water, regular water, if you see right here, regular water coming in, and it went from H2O to OH, and this OH is going to be very reactive in the body. This O2 minus and this OH plus are very reactive in the body. They like to go and hit things. They like to destroy things. They like to damage things. So that's why we need antioxidants, and that's why we consume fruits that have antioxidants, because these antioxidants come and we can say neutralize this and this, okay? So yeah, they're called reactive oxygen species, and excess reactive oxygen species causes oxidative stress linked to human chronic diseases such as cancer, inflammatory, neurodegenerative, or cardiovascular. So what this means is that the more reactive oxygen species we have in our bodies, because they like to do a lot of damage, we can have things such as cancer, because it can it can damage the DNA in our cells. It can also cause inflammation because now it's there everywhere, and our bodies think that these are just some kind of weird stuff that came from outside, and they create inflammation. Well, it depends where they accumulate more. They also cause neurodegenerative or cardiovascular. They can travel to the brain. You can imagine what kind of stuff they might be doing. Cardiovascular disease. Um, Again, it just causes a lot of stress. The stress might make you want to eat more, things like that. Now, what are the routes of exposure and toxicity of these nanoparticles? As you Well, first, the routes of exposure are usually ingestion, inhalation, and thermal exposure, as we already talked. They're used in sprays, uh, also sunscreens, but spray. You can also inhale them in paint, uh, aerosols, and also a regular paint. Um, that's the particles from decaying paint, and you can also ingest them through food. E171, as you can see right here, ingestion is whenever they're in food, it's called food additive E171. France banned E171 due to lack of scientific data to confirm safety in 2020. That means that there's a lot of debate whether these things are good, whether they're not good. um, some scientists, they say that they make a lot of experiments such as the mice, epithelial cells. They show that these particles can be toxic, can cause inflammation, cancer, a lot of things. But it all depends on how much you are taking in. What's the dose? Because let's say if the recommended diet is 2000 calories and you're eating 10 skittles, for example, then then that's your problem. The agents are going to be like, hey, we told you to only eat 2000 calories, you're exceeding the amount, so that's your fault, you're consuming more than we're telling you to consume. But regardless, look over here, as you can see right here, it says titanium dioxide and skittles, and also in toothpaste. Right here it says, where can we see it? Right here, titanium dioxide. In some foods it just says E171. On some foods it actually says titanium dioxide. Um, Now, local effects on titanium dioxide nanoparticles on the intestinal barrier and changes in the gut microbiota. What this scientist found in 2014, Botello, Urrutia, Ortega, and others concluded that titanium nanoparticles, they can just damage the gastric epithelial cells. So the cells that are in our gut, as we are consuming all of this, they just damage the gut. They provoke tumor-like phenotypes, proliferation, increase of apoptosis, decrease in human gastric epithelial cells. What this means is that they did an experiment and they showed that this the more titanium dioxide nanoparticles were present in these gastric epithelial cells, rather than rather than killing the damaged cells, the damaged cells started to grow more. In other words, cancer, right? because cancer cells, they're damaged and they just keep growing and growing and growing and growing, and they don't stop. So this caused a similar response. The cells started to grow more and more and more, rather than just say, hey, there's something weird here, let's just not grow right now. But they kept growing. Now they also saw an increase in glutathione levels. um, the glutathione is just we can say it's chemistry that the body does. It's more the body creates antioxidants that is going to reduce the oxidative stress. And the scientists, they saw that I forgot whether this was done in mice or just in just cells, but the point is that the cells are damaging the cells. No, sorry, that these nanoparticles are damaging the cells. They also created DNA lesions. They decrease intestinal microvilli with decrease in absorption and worsens pre-existing intestinal disorders. So if you have an intestinal disorder, just avoid at all costs taking anything that has titanium dioxide nanoparticles, because it's going to worsen the inflammation. Okay, that's the point. Now, thermal exposure. Titanium dioxide nanoparticles as a sunscreen compound. Now, yes, there's a lot of debate in this area whether these are good or not. Scientists, they show that these are good for the skin. We wouldn't say they're good. They just worked. They are able to block the UV light. The UV light, they protect the skin, but there's some debate whether these things can penetrate the skin through wounds, because sometimes um, we put sunscreen on wounds, or also we put sunscreen on damaged skin. Let's say you put the sunscreen on sunburned skin, which is already damaged. So we don't know if these things are actually penetrating through the skin and accumulating in the tissue. So the International Agency for Research on Cancer, IR IARC, includes titanium dioxide in the list of possible carcinogenic to humans. So what they said is it might be possible that this might be causing cancer, but we don't really know for sure that they are causing cancer, because there's a lot of different factors that are involved in this. Okay, so the conclusions are that mm, these are some of the conclusions. Um, we can say in foods, yes, absorption from the let's read this here. The absorption of titanium dioxide from the digestive tract generally considered extremely low. Um, what they're saying is that some of these nanoparticles might be absorbed in the digestive tract rather than being expelled, but as they say that it's low. That's what some people say. Okay, that's not what some experiments show. That's just what sometimes we are led to believe. Now, safety on the long-term dietary exposure to titanium dioxide nanoparticles. Let's say you eat a lot of candies with these titanium dioxide nanoparticles. We still don't know. Potential toxic effects may concern the absorption, distribution, and accumulation of titanium dioxide nanoparticles. There's not a lot of scientific data or experiments showing, let's say, that these kids, the kids that were eating these candies with these particles, develop cancer because of those particles. There's a lot of things involved, not just these candies, right? So it's hard to know. Potential risk caused by titanium dioxide nanoparticles: genotoxicity, inflammatory response, and carcinogenesis. Just means that it can damage the DNA, it can cause inflammation, and it can be a carcinogen. So lack of established acceptable daily intake limits. These are the conclusions. Is not We don't really know how much we should be. Scientists don't, they cannot just conclude that they're bad, because they need a way to say they're bad only if you're taking this amount. It's just tough. Some industries, there's not a way to know how much particles are in each Skittle. So if you're eating one Skittle, you might be taking a little bit, but if you're eating hundreds of Skittles, you might be taking a lot. And there's not really a recommended dose of these nanoparticles in our body. a daily intake, right? Now over here in the sunscreen formulation, there's lack of standardized guidelines for the quality control of sunscreens. Um, there's just really no guidelines for or regulations in these industries that are making these sunscreens. So I guess nobody cares that much anyway.